Now we will begin our Seneca Tornado training exercise. To get started, we'll use the Intel Manager app. The purpose of the Intel Manager is primarily to edit waypoints, tracks, search segments, and operational areas. But it's also where we can search for other intel to add to our map. Your tech info specialist or GIS specialist may be the primary user of this app. However, the geospatial intel generated is used across the platform. The first thing you should know is we've added on-screen instructions with links, identifying each component of this application. The instructions describe the tools that are available across the top of the app. Please read these, as this video is just a brief introduction. These tools across the top are called widgets, and they help you to accomplish tasks like zooming to a predefined area using bookmarks. The layer list widget allows you to turn layers on and off. This can be very useful for reducing clutter if there are too many layers on the map. We can also change the backdrop or base map of our map using this base map widget. This includes turning on imagery for a different perspective. Like most web mapping applications, we can search for a place and use zoom buttons or the mouse wheel to zoom in and out. Finally, one trick we like to share is that you can hold Shift plus draw a zoom box with the mouse to zoom into an area. These are all basic widgets that allow us to navigate and temporarily change the appearance of the map. For severe weather event readiness, we'll want to add some authoritative forecast data to our map. To do this, we might use the Add Data widget. Since we're concerned about tornadoes right now, we'll search for that keyword. Before the Seneca tornado, South Carolina Task Force 1 was monitoring the Storm Prediction Center's severe weather outlooks, long-term weather warnings, and short-term weather warnings. These short-term warnings indicate that severe weather is imminent. We encourage you to explore other relevant live feeds of data using the Add Data tool for your area. Let's take a look at the short-term warnings issued by the National Weather Service just before the tornadoes touched down in South Carolina. We archived some of the data for this exercise. This red area indicates a tornado was very likely to form. Next, we can see a few confirmed tornado reports by turning this layer on in the map. All of this information combined should give us enough to determine our initial incident area. The Smart Editor is a widget that allows us to create and edit our own incident data before we even go into the field. Let's start with defining our incident area. First, we can search for the incident area palette and click on it. This activates the editing capability. In this case, we'll quickly hand draw the incident area using a large polygon to cover all the known tornado events. We can clean this up later. Once we've created a new area on our map, we can add attributes if we have time. These attributes will show up elsewhere, including map pop-ups. Think of these as the data behind the map. When you're done, be sure to click Save. Now, let's turn off some layers in the map to reduce clutter, using the layer list. For this exercise, let's focus on the tornado near Seneca, South Carolina. Here is the preliminary tornado swath determined by meteorologists and hazard specialists. Similar to before, we can add divisions to our map by selecting the layer in the palette below. But now, we're going to click on the Select tool. Since it's the best available information for this tornado, we will use this swath as our first division. We will select it, and now we're going to copy this source layer into our division layer, making sure no other layers are selected, and then clicking Create Features. We can name this the Seneca division, or use a simple letter designation depending on the scenario. An incident support team member will likely use this or a similar method to designate divisions for each unique geographic area that has been impacted. Now we will add our first search segment to the map within the Seneca division. These can be hand-drawn, imported from US National Grid, or in this case, we can use some existing boundaries to speed up the process. Again, we can use the Add Data widget, search for census tracts, add them to our map, and then copy them in the same way we did before using the Smart Editor. Census tracts tend to make balanced search segments that can be identified in the field by roads and water bodies. Our GIS specialists can trim these and clean them up later on. Because we are using geospatial tools, these search segments contain data that we can use for decision making. For example, when we click on the pop-up, not only do we see the data we've entered, we can also auto-calculate information like the number of buildings and area of this segment. This can help us estimate the amount of time it'll take to perform a hasty primary or secondary search of each structure. Finally, we can add some waypoints to the map, such as an incident command post. Looks like it'll be Station 7 in Seneca at the address I'm typing in here. That'll zoom us to it. And again, we can simply use the Smart Editor to add this point on the map. From here, we can continue to build out the map even while teams are already out in the field. The best part is their field maps will update in real time, or they can take them offline tonight for the next day's operations if needed. And of course, we can still print paper maps. We can do it from this application or work with a GIS specialist to pull these common operational layers into their desktop GIS software. In the next part of this video, we'll move into the response phase using the field apps. For most field team members, they can skip straight to this part. We felt it important to give you the context for how the Intel Manager can be used to build the common operating picture.